And David Raiklin, who's an anthropologist, he's kind of argued that our brains really have evolved to be engaged when we are active. So that there's a kind of evolutionary reason why we would expect, not just as a side effect, but why we would expect our brains to be kind of engaged by physical activity. Sorry, there's a whole load of words. I'm not sure I'm answering your question.
No, you are. Yeah, you are. You definitely are. Okay, yeah, that's pretty interesting. So you mentioned that, the brain kind of like was wired to be cognitively engaged while we're in physical activity, right? Which is pretty interesting, because normally if you talk about feeling motivated, you normally only feel motivated after you move, right? It's hard to feel motivated if you're not doing anything, right? So I think, oftentimes, feeling inspired and stuff like that, it comes from being active. So that's really interesting. Now, one thing I want to talk about is like what actually happens though to the human brain when we adopt a sedentary lifestyle? Because obviously you mentioned having that oxygen flow, having your blood circulation and so on and so forth. But outside of that, like what happens to your brain when you stop being physically active?
Well, thinking about what we've just said, that if at some point physical activity has driven mental activity, and that's like a design feature, not an accidental relationship, then of course we would expect those positive effects to be reversed or neutralized or not happen when we're sedentary. So what seems to happen when we're physically active is we get changes in blood flow, which have positive effects. We get changes in oxygenation and fuel. We clear waste products out better. We also get a whole cascade of sort of chemical changes which affect various processes. And some of the most important of those are ones that support what's called neuroplasticity, which is how our neurons connect to each other, how flexible they are, whether they can make new connections. And that fundamentally supports memory and learning. In some creatures, we actually get neurogenesis. We get new neurons as well, but that's quite controversial in humans. We think it happens in some regions. But what that means is there's more possible capacity for learning as well. So if we're not active, one of the key changes is our sort of brain is not so well nourished. Inflammation tends to happen, which is a whole complicated story, but there's more inflammation, and that tends to be quite detrimental. And we tend to start losing connections. They're not stabilized, they're not maintained. And that gives us then less of a kind of capacity for potential future learning. So what we actually see if we're sedentary is we see the brain shrinks, we get less connections in the brain, we lose white matter, we can get volume loss, particularly in certain regions. We get less new neurons and less flexibility of our neurons. But we also get a whole load of other effects as well. So glucose metabolism gets changed. We can become. That means we're getting less energy supply. We see changes in mitochondria, which are like the little energy creating units in our cells. We get changes in hormone levels, reduction in some of the good ones, and increase in some of the bad ones. These can all affect motivation and mood. And we get changes in the gut as well. And the gut communicates massively with the brain. So changes in the gut can trigger inflammation in the brain. Inflammation in the brain is very negative. So there's this huge cascade of effects, some of which may be almost accidental and side effects, but some seem to be very, very direct. And they support this idea, perhaps, that what happens when we exercise is that our brain is sort of put into a more optimal state, if you like, for learning. But it also affects sort of mental health and mood regulation as well, because we actually need those capacities to solve some of the problems and some of the tasks.